Okay, so today, as you can see, is the first day of chapter 6.5, 6.5. It's all about complex fractions. So this was a really good spot in chapter 6 to break away from the other stuff. So we're still talking about rational expressions, meaning fractions, but it's kind of a different take on it. So you'll see a lot of similarities to the first part of chapter 6, but you'll see why this is on its own as well. Does everyone have a new notes packet? We good? This is a pretty short section or chapter and a half, so that's why it's so skinny. I'm almost done with your test. I would say by 3:30 they'll be in the grade book, so just keep an eye out for those. I have no idea what the average grade is right now. All right, so here's example 1. In your packets, there's a little bit more information. There are 4 steps to doing it. It says steps for simplifying complex fractions. And we call these complex fractions because they're fractions within a fraction. Or 2 fractions within a fraction. Okay? The first thing you want to do is split the big fraction into a division problem. So there's usually a big fraction bar. A bar that's a little bigger than the others. We're going to rewrite it with this as a division symbol. Okay? Then you simplify the expression in front of and after the division symbol. Then we do the keep, flip, change, and simplify. Okay? So, here is the big bar. Everybody see it? So I am going to just rewrite what's in front. I'm going to write the bar as the old school division symbol. Then I'm going to write what's underneath. Everybody with me? Can you simplify a over 6? Can you simplify 2a over 3? No, so we are to the keep, change, flip step. All right, can we do any cross-canceling? The 3 and the 6 can become a 1 and a 2. The A and the A. So we are left with just a 1 in our numerator and 2 times 2 in our denominator. 2 times 2 is 4. All right, that is example 1. What are your questions? All right, here's number 2. All right, once again, we are going to rewrite this. Where I see the bigger fraction bar, I'm going to write this old school sign. So it's going to be b minus 2 over b plus 3 divided by b minus 2 over 3. Can I do any simplifying? Nope. So what I'm going to do is keep, change, flip. Okay, if someone tells me to cancel the 3s, I'm literally going to lose it. Do not cancel the 3s. A lot of you still want to do that. Like, oh, there's a 3 here, there's a 3 here. Why is that not okay? Why am I getting so frustrated? Those are terms. Can we simplify terms? No. What would I need if I wanted to simplify them? Yes.
A B in front, like a B plus 3.
Yeah, I would need like a B plus right here. Do I have that?
No.
I do not. Or I would need to get rid of this one right here and have a 3 and a 3. Do I have that? No, you can't do anything. They are different expressions. They're different terms. They have a different value. Don't mess with them. What can I mess with? The b minus 2s, it's the same factor. It's the same binomial. We're good to go. So on the top, what do I have? 3. And down below? Can I cross out the 3's now? No. Good. You cannot. Some people, they would do it right, and then in the very last step, they just start crossing all this crazy stuff out. No. So you gotta know when to stop. All right? We are done. Any questions? Now, on that same note, if you are feeling the desire to cross out those 3's, it is time to explore some tutoring options, okay? There's tutoring before school. There's tutoring after school. There's tutoring during every single lunch hour. But you have to go to tutoring. There's the key, okay? So if that's you, it's fine, but it's time we take care of it. Because pretty soon it won't be fine. We're getting into the second triad of the semester, so it's go time. Any questions? Okay. Example 3. What shall I do? Rewrite it. Then what? Yes, this is going to turn into a division sign. All right. Can we do anything with anything?
Yes.
What can we do?
W squared minus 16.
Is what?
Dots.
Yes, that's a difference of squares. So I'm actually going to rewrite it and factor that one at the same time. So this guy's good. Keep, change, flip. And when I flip it, how would I rewrite w squared minus 16? W plus 4 times w minus 4. Booyah. Now what's going to cancel? The w and the w plus 4 and the w plus 4. 1 over w minus 4. And I'm done. What are your questions? All right, what am I going to do? Yeah, so I'm going to rewrite this. And it's actually kind of helpful if you think of this as being grouped together and this guy as being grouped together. You have to simplify what was originally above and what was originally below before you can divide. Now, how do I do m over n plus 1? Like if I wanted to make that one fraction, what would I do?
Don't you make it so that it's like, so if 1 goes into n, it becomes an n, so it'd be n plus n. On the top.
So what do you have to get?
You have to get it in the denominator.
Yeah, we have to get common denominators. Is that what you're trying to say? Yes, okay. So the LCD up front is n. Okay. So I'm going to rewrite this. First guy's fine. How could I rewrite 1 with the denominator of n? N over n. Good. You just think of 1 over 1 times n over n. All right, still dividing. What's going on in the back?
Same thing.
Same thing. I can do n over n to get common denominators. And these are all equal to the step above it. All right, so now I'm going to start writing over here. So up front, this is m plus n over n. Still dividing. M minus n over n. Now what? Change it to multiplication. So this guy is fine. Change this, flip this one. All right, what do I do? Cross out the n and the n. Now what? Does that equal 1? Does it equal -1? It does not. Nope. The n's have different signs. The m's have the same sign. So even if you like pull out a negative or multiply through by a negative, you're never going to get all the signs to match. So that one is actually done. It's as good as you're going to get. Questions? All right, number 5. Yeah, do you guys see on your notes it says example 4 and then you flip it and it says example 4? Just make that 5 and then 6 and then 7. There are 7. All right. Anyone have ideas? Yes, we're going to rewrite this as division, and I'm going to keep the numerator in parentheses so that I know I need to simplify that first. Divided by, I'm going to keep the denominator in parentheses so I know I need to handle that first. Now what? Yeah, we need to get an LCD up front. What's my LCD up front? 2. What's my LCD going to be in the back? That's the 4. Good. All right, so this is going to be x over 2 plus what? 2 over 2. Good. Think of that as 1 over 1, and then you're multiplying 2 and 2. Good. Okay. Divided by x over 4 minus 4 over 4. Perfect. Now you can go ahead and combine those. This is going to be x plus 2 over 2 divided by x minus 4 over 4. Now I can do what? Keep, change, and flip.
Simplify the 2 and 4.
Yeah, the 2 and the 4 comes a 1 and a 2. Now, up top, I have 2 times x plus 2. And on the bottom, I have 1 times x minus 4. So that's going to be 2x plus 4 when I distribute the 2, and then distributing a 1 doesn't change anything. Can I cross out the X's? No. Can I cross out the 4s?
No.
No. That's as simple as it gets.
I could have sworn we had one of these on the test.
The bonus was a complex fraction on your quiz. Or your test, I mean. I have not got to that page, so I'm not sure if anybody got it.
I didn't even know how to solve it, so. Oh no.
All right, number 6. All right, what should I do first? Rewrite it. So 4x over 3 plus 2 divide by x over 3 minus 3 over x. What is my LCD in the first set of parentheses? The original numerator. LCD is going to be 3. So this guy's good to go, right? How do I turn 2 over 1 into something with a 3 on the bottom? Yeah, multiply top and bottom by 3. So times 3 times 3. So that's going to be 6 over 3. Perfect. What is my LCD going to be in the back?
3x.
3x. So the first fraction gets multiplied by x, and the second one 3 and 3. This is going to be x squared over 3x minus 9 over 3x. All right, moving up top. So 4x plus 6 over 3 divided by x squared minus 9 over 3x. Okay, so the x squared minus 9 can be factored. It's a dot. 4x plus 6 can be factored. And what else can I do at the same time? Keep, change, flip. Get rid of the division. Make it something we can work with. All right, so 4x plus 6. Let's start there.
You can factor out a 2.
Okay, so that's going to be 2x plus 3. Now, I don't know if that's going to be a productive move or not, but I'm going to go with it. Okay, change, flip, and then how am I going to write x squared minus 9?
X plus 3, x minus 3.
X plus 3 and x minus 3. All right. Huh, I thought a little more would go away. All right, it's gonna go away? Just the 3's, right? 3 and 3?
Can you do that? I thought you couldn't.
Yeah, they're both monomials, so you can cross out the 3's.
If they're monomials,
Mm-hmm.
and if they're binomials and they're the same factor.
They have to be the exact same. Like 2x plus 3 and x plus 3, because the one's missing a 2. You know what I mean? All right, so up top we have a 2. We have an x, and we have a 2x plus 3. And then in the denominator, we have that difference of squares. All right, I'm going to multiply everything out to finish up. That's going to be 4x squared plus 6x over, and then when you distribute that, you should end up with the original difference of squares you started with, or you factored it wrong in the first place. So I had some hopes that some more would simplify out, but it does not. Wah wah. Questions? All right. Yikes.
Oh my God.
And this is where you just skip it, leave it blank. There's a lot of blanks on the test. It's a little disheartening.
I go get a drink of water.
Sure. What a great time to go get a drink of water. Okay, so let's just start rewriting it as division. Let's just start with what we know. Take it slow. A squared plus A minus 12 over A squared plus 3A minus 4 divided by A minus 3 over A squared minus A. Now what? We can do MA. What multiplies to negative 12 and adds to positive 1?
4.
So A plus 4, A minus 3. That would give us a negative 12 and a positive 1, correct? Okay. We also want A multiplies to negative 4 adds to positive 3. A plus 4 A minus 1. Thank you. Can we keep change flip at the same time? You guys all down with that? It's not dots. I mean, just listen to how I say A squared minus A. Yeah, there's a lot of A's happening, right? So I'm going to factor an A out while I'm flipping. Okay? So if I factor an A out, what do I have left? A minus 1. And then A minus 3 is good to go in the denominator. All right, now the fun begins.
Cancel out the A minus 1s and the A minus 3s.
So the A minus 1s. The A minus 3. The A plus 4. Now all you have left is an A. Hey.
That was it.
That was it.
I didn't think you could take out those A plus 4s.
Yep, any numerator and any denominator after you keep change, flip. Yes, even if they're in the same. No, like, nope. If they're right on top of each other, that's just, you're just simplifying from the original expression. Yep, good to go. All right, any questions? What did we start talking about today? What are these called? Complex fractions. Good. All right, so here's how this is going to work. Are you ready? Not done yet. You have homework today. It's day 1. Tomorrow when I see you, we will do another lesson. You will have another homework assignment. That is day 2. I will not be here on Monday. You are doing a PSAT practice test in class, and then you're doing day 3 worksheet. And I'm going to check all of it on Tuesday. Day 2 from Friday, day 3 from Monday, and the PSAT review. You need it all.
Why did that just sit the show?
Any questions?
So we're getting a